Hey everyone, I'm Tim Dennis. I'm from UC OSPO LA. I decided to start calling it that. UC OSPO LA. It's kind of old. I'm really happy to introduce our next speaker, Kate Hertweck. I met Kate through the Carpentries, which is a global teaching community for data science, where we co-taught during the early days of COVID, bleary-eyed. We were both part of a cohort for exploring collaborative lesson development in the Carpentries. That collaborative lesson development material we're going to use in the second year of the Sloan Grant that's funding UC OSPO, which is kind of a cool interconnected point. Kate is one of those rare educators who immediately makes learners feel included, attuned not to just what's being taught, but how it's landing. I learned a lot from teaching with her and continue to admire the care and thoughtfulness she brings to everything she does. Kate is now program manager on the Open Science team for Chan Zuckerberg initiative, where she supports open source tools, platforms, and communities advancing biomedical science. Before joining CZI, she built a career at the intersection of plant genomics, cancer biology, and bioinformatics training, all while staying deeply involved in community-focused education and governance. Please join me in welcoming Kate Hertweck.
Thank you so much, Tim. That was a really, really kind introduction. I hope that I can continue the good vibes as we wrap up today with what I personally believe is a great way of thinking about open source software. And that is answering the question, why do we open source? What difference does it make? What is the impact? And so today I'll be telling you about a large project that I worked on last year, summarizing some data that we were able to collect as a part of the Open Science team at CZI. Before I dig into the details of this report, I want to give you a little bit of information to help contextualize the things that I'll be talking about. And the contextualization, I want everyone to know that I love your open source projects. However, I work for CZI, so I have to love the biomedical projects the most. The ultimate goal of CZI, our end of the century goal, is to cure, prevent, or manage all diseases. Over the next 10 years, we're focusing more on basic biology, hoping to develop technologies to measure biology in action and understand how the cell works. What this means in terms of how we operate is that CZI is a philanthropy with multiple types of approaches to addressing these big societal questions around human disease. We fund projects, meaning that we have worked with grant making in the past to ensure that we have the types of tools available in the community to meet the needs. We build technology, meaning we have a large collection of software engineers developing open source tools that are specifically targeted at certain questions. And we also do science through the virtue of now 3 research institutes referred to as the BioHub networks. One of those in San Francisco, one in Chicago, and one in New York. The nice part about open source technology is that it resides at the center, the intersection of all 3 of these areas. We fund open source, we build open source, and we use open source tools in our research. As a part of the Open Science team that I've been with for the last 3 years at CZI, one of the main ways that we've supported open source software is through our Essential Open Source Software for Science program, or as we call it, EOSS. The premise behind EOSS is that it is incredibly difficult for software projects that are fully mature, meaning they are not being developed for a very specific research purpose. It's hard for these mature projects to find funding to help with the maintenance and ongoing development, resolving tech debt, or building out a user base. And what EOSS attempts to do is provide funding specifically for those maintenance purposes. You can learn a little bit more about the program using that short URL. This is both the best and worst slide. It's the worst slide because it's too many letters. It's the best slide because hopefully you can find one of your favorite open source software projects here. These are all of the projects that EOSS has funded between 2019 and 2024, the duration of each of the 6 funding cycles. And a quick overview in a little bit more legible manner than a slide full of letters. We've had 6 funding cycles with over $50 million. That means that we have reviewed over 2,000 applications. The $53 million has funded 195 individual grants. Because each of those grants may have between 1 and 5 total software projects associated with it, we've actually funded 233 software projects. In the 6th and most recent cycle of EOSS, we collaborated with other organizations, including 2 other funders, Kavli Foundation and Wellcome Trust, to be able to provide even more funding from diverse sources. To our knowledge, this is the largest fund to support scientific open source to date. This is also a good point for me to say and remind you, we talked about a lot of different perspectives on open source today. For the purposes of this talk, I'm going to be primarily referencing scientific open source software, which we tend to define as research software largely hosted by academic institutions, although that's not necessarily a hard and fast rule. But in general, these tend to be focused on specific areas of scientific research, both very specific focus, as well as more foundational tools, meaning things like file formats that underlie a whole lot of different open source software projects. And to flesh that out a little bit more, this is a diagram that shows the number of proposals by categories of biomedical research as we define them for the purposes of the review process. You'll note on here that imaging, for which CZI has a very strong focus, we funded a lot of projects from there. Data management and workflows and machine learning and data analysis are large, very general categories that include things like NumPy that may actually be used by things outside biomedicine. And then we have a number of more specific areas within life sciences or biomedical research. I wanted to give you a little bit of information about the types of information we request from applicants, and that's for the purposes of understanding where some of the data are going to come from later. So we ask for a basic scope of work, not surprising for a grant proposal. We ask for which open source software projects are going to be supported by the grant, between 1 and 5 projects. Usually most projects say it's between 1 and 2 different groups. And for each of those projects, we have both user-submitted metrics as well as GitHub-derived metrics. And we ask questions about the different components of the project that are available to members of the community. We ask for a statement about the value to biomedical users of the software in question. And again, it's because some things are very obvious. This is for aggregating clinical research records. And in some cases, it's not quite so apparent. We need a bit more information about who the biomedical users are for, say, a given visualization package. We also ask for a landscape analysis, which generally compares the piece of software being proposed to other similar tools, both proprietary and within the open source community. We evaluate all of this information based on a number of criteria, including things like the impact of the software or potential impact, the quality of it, and feasibility of the work plan. A bit more information about project metrics, because I think this is a really interesting intersection, like how do you quantitatively assess the impact of software? We ask for a number of pieces of information within the application, like number of citations, number of software dependencies, number of users or visitors to a website in whatever way that the project defines that or can assess that. These are not all required. It's useful information for us to have. We also pull down statistics ourselves from GitHub, and this includes things like number of stars, number of forks, contributors, the number of commits and issues available, and we combine all of these data together and have some nice graphs. And this basically helps us with the review process. We understand not everybody hosts on GitHub, but it does allow us to speed things up a little bit when we're sorting through hundreds of applications. Some of the things that we found, even early on in the early cycles of EOSS, is that the projects that we end up funding generally have more robust development practices, meaning that for each of the different pairs of bars represented here, there are a number of different things that should be familiar to you. Does the software package include examples or demonstrations associated with how to use the software? Is there a contributor guide? Is there an issue tracker? And for almost all of these, we find that funded proposals more often than unfunded demonstrate these software best practices. This is sort of like a gut check for us in ensuring that the types of projects that we're supporting are modeling the types of things we like to see in the open source software community. Now, this is one way of leveraging the data, meaning the information provided to us by our applicants, and being able to understand what our particular program means. Right? We can say, okay, here's some data that helps us understand these patterns. I spent an embarrassing amount of time last year. I call this my second dissertation, because one wasn't enough, although I don't actually get credit for this one in that kind of way. In putting together insights and impact from 5 cycles of essential open source software for science. There's a short URL here and a QR code if you'd like to view this on Zenodo. There's some supplemental data that's included in there. The report's also 80 pages long. I'm almost embarrassed to say that. People gave me a hard time for that for like months after we released this. My mom even said she's 70 years old and is a former English teacher in middle school, right? She said, I read all 80 pages, but I didn't look at the figures. I'm sorry. And I was like, you don't need to apologize for that. And so what I've done here is synthesize a few of the big findings that came out of this report. In general, by funding mature scientific open source software projects, we found that solutions for critical technical needs of projects, meaning things like tech debt, developing interoperability with new and emerging packages, that is accelerated by the projects we funded. We found that we can actually identify connections between specific scientific outcomes and the specific projects that we have funded. We found that documentation and community support resources like tutorials or having community managers was measurably improved by our EOSS grants. We found collaboration among software projects, both within projects in the same grant and within members of our community. And we found that we were able to identify specific places in which participation of individuals across many different demographics in the world were able to engage in open source software. We're going to spend a little bit more time talking about some of the specifics here, so hopefully I can convince you of 2 things. The first thing that I want to convince you of is if you are developing open source software, there are lots of ways that you can demonstrate the impact and meaning of the software you work on. The other thing that I would like to convince you of is that if you are looking across many different software packages and trying to compare them to each other in terms of things like success, that's actually a very hard thing to do. And in fact, you have to have a little bit of finesse. You have to have quantitative and qualitative output, and you have to find some sort of way to square the variation in software. Now, the reason I can say all of that is because for each of the different dark boxes represented here, or stages in the application and funding process, our team derived a number of pieces of data or information from it. And those are each represented in the light oval boxes here. You know, you don't plan for how to talk about something when you're creating figures. That's something I'll learn from in the future. So The details about each of these data sources and some of the output data from these, insofar as we're able to within legal restrictions, are available with the full report. But basically, the data includes both survey-based data, assessments of what grantees told us they needed during the course of their research, and a variety of other NLP-derived, so the application corpus analysis and CZ software mentions, actually screen through the applications and scientific papers to be able to derive large-scale aggregated data. And all of this was really valuable when trying to put together a picture of what our work meant. I'm first going to start by helping us think a little bit about what the scientific community of open source software developers, what they need and what they want when they're engaging in their work. Then we'll look at the idea of the production of these grants. What activities did they engage in, and what came out of those activities? The first question is basically assessing the needs of projects that are funded. Now remember, when I say projects that are funded, these are already mature, meaning that they may be trying to address a number of different issues within their package. And so we wanted to know, are you having trouble resolving technical issues? And based on the data here, we asked about a variety of different perspectives of technical capacity. And we found that most of these people generally feel good about them for their software projects. They feel capable of addressing these needs themselves. It's not saying that their problem is resolved, but they feel like they can address them. We also asked about their ability to engage in documentation-related issues. And in this case, there were a few more areas that had a bit more need. Again, I'm generally looking at the things that people say they urgently need. So documentation capacity was a little bit more urgent than technical. But then community-related capacity had some areas where not super concerning, but some areas where there was definitely room for improvement. And I have to say that as a part of the grantee support for the Open Science program, we engaged in a number of support activities like hosting workshops or offering training to be able to invite participants within our community to resolve some of these needs. But I think it's telling to say this is what mature projects are generally concerned about. And then if you take the flip side and say, okay, based on what we know the grantees did during the course of their projects, what types of things did they produce? On this slide, there are two different categories that I want to draw your attention to. The categories that absolutely do not show up when projected here are the top four: technical, community, documentation, and training. These are what we consider to be software project-based outputs, whereas the bottom four, manuscript, presentation, proposal, or grant, and data, are things that we can consider traditional scientific outputs. And again, being able to compare and weigh what different portions of the community engage in is sort of telling in terms of the nature of the teams and the types of things they consider important. What this looks like, removing technical as a category, because spoiler alert, everybody has technical outputs. Surprise, surprise. It's actually kind of a nice validation that our methods weren't total crap, that we did actually identify everybody submitting pull requests. Great. Out of all of the remaining, we found that the software development needs are, by far, the most frequently reported activities that folks engage in. And in fact, anecdotally, anyone engaging in a training activity also engaged in a community-based activity. So those were not completely independent from each other. I was actually kind of surprised that we had so many traditional scientific outputs being reported by projects, because again, this is the proportion of projects that were reporting these types of outputs. And this is probably one of my favorite pieces of information from the entire proposal. We were trying to aggregate and analyze across a huge variety of information. One of the challenges of this project is that we did not set out with the intention of doing this type of work in 2019. I wasn't even on the team then. And yet, we had all of this data. What data were those? Well, here I presented some different categories of data and then the examples of types of things. And these are pieces of information that grantees reported to us. And a lot of what we've learned from this is that people in our grantee communities often care about a much larger picture than we do when we're looking at the types of accomplishments for their grants. And what I think that means is that we have to take a more holistic view, or at least be able to communicate ahead of time what the most important metrics are. And that's hard to do when you're talking about a wide variety of software projects. And so I'm going to spend a few more minutes talking about the punchline. Like, why do we care about this at all? I mean, I think you all probably care a little bit about types of outputs because you're sitting there thinking like, okay, what am I actually doing in my software project? But everybody else in the world cares about the impact. And the questions like this are, why does this work actually matter? How does it relate to an organization's goal? An organization may be, say, your university. It may be a professional society. It may be your lab. In our case, we were trying to answer a basic question: what is the impact of EOSS as a grant program? The first thing I'll say is that we were interested in understanding how funding supported the projects themselves. To me, this was also quite a disingenuous question. Everybody likes money. Everybody likes being able to pay their people. But breaking it down into saying, how important was this to, say, the success of your project? 95% of respondents said that it was extremely or very important to the success of their project. And remember, this is a mature project. So we're not talking about building out an entirely new piece of software. We're talking about maintaining some of the most important and most widely used software packages in biomedicine. An example of this is from PsychoPie, who was able to bridge a gap in commercializing their model, in being able to develop that revenue model and keep their people going until they were sustainable. Another question is how the maintainers of that project were affected. 85% of survey respondents also had very positive responses for this. One example I liked is Network X, who noted that hiring a community manager let their maintainers or their developers focus on things that they were specifically hired to do, the actual software development, and that being able to focus their energy on that particular thing was a very striking difference. Of course, as I prefaced at the beginning of this talk, we care at CZI a lot about research. We have to connect everything that we do to the outcomes specifically for biomedical research. And so 74% of respondents told us that this funding was very important for the uptake and use of their project in the biomedical research community. Again, that's a very specific question. We're trying to assess, did it help people in biomed get more work done, right? Did this make their software accessible? And so I have kind of two different answers to this question that I can talk about individually. One is about basic usability of the software and expanding the user base. And I have two examples here. 7% of projects were able to translate their materials to additional human languages, such as providing videos with translations to different languages. And then a quarter of projects identified outreach to new groups, like folks in different areas of the world, or different members of the community that they had not previously engaged with. So again, this is great. This is very specific information for us about how more scientists or more users in general are engaging with the software. Again, the real gold star we're looking for is being able to tie specific pieces of software that we have funded to specific outputs in biomedical research. And so I put a few examples here of the types of connections we found. We found that software projects expanded their features to support specific biomedical cases that might be improving microbiome studies with a phylogenetic package. We also found that some projects had their software included in platforms that are specific for biomedical research. And so in some cases, this means some of the widely supported or nationally supported platforms made that software available to a wider variety of people. This also includes having software that's available on training platforms. And then finally, we also have examples of high-impact biomedical research outcomes. I think I would be surprised if we haven't heard anything about AlphaFold at this point in time. I feel like every talk I go to, every meeting I go to has, I know, you feel me.
Yes.
And so, of course, we can identify the specific software packages we funded that are included in that. So sort of piggybacking on the success. Again, arguably, the question is, would AlphaFold have been able to be created without some of the packages? Maybe. Would it have been created as quickly? Would it be as robust? Hard to say, but we can still make this connection. Another area that we are particularly interested in is being able to connect to the real currency of science, which are citations of particular pieces of software, citations in scientific literature. The hard part is that scientific papers generally don't formally cite software. Does anybody feel my pain? Okay, I don't need to say much more about this. What I can say is that software is often mentioned in a paper, meaning that if you have nice enough software tools to screen through all of that literature, you can identify a broader variety of papers that have used the software. And so CZ Software Mentions, which is an entirely different talk that you'll have to find Dario Taraborelli, the team lead for the Open Science program, to talk more extensively about, did just that. Went through over 20 million papers to identify all of the cases in which pieces of scientific software were mentioned. There's a lot more documentation associated with this. My punchline is that I pulled the data for our EOSS supported projects. There's no good way to show this data in any meaningful way without cherry picking. And so what I did is pull the top 10 software projects by total number of mentions. It's interesting that, again, this represents kind of the full breadth of categories of projects that we've supported. There are a number of imaging-based projects here, which again is not surprising. There was that list of the most cited papers of this century that just came out not too long ago, and I think 3 of the top 10 are imaging papers. So that's like a trend in the literature I keep thinking about. But again, being able to see the general increase in citations over time, this is a nice litmus test for us. Are we continuing to support projects that are being used in literature? Again, imperfect data, but still data that we can use. So I wanted to end with a few of sort of the things that we've learned associated with EOSS. The question is, what happens after this? We have some information about software impact. But what I want to say is that the insight about scientific software is not limited to impact. We actually know a lot about what it means to fund mature scientific projects. Early on, like the first cycle of EOSS, it was only for 1 year of funding. We learned pretty quickly that having a modest amount of funding over an extended period of time is much more useful. And so that was something that changed in subsequent cycles. We started giving 2 years of funding. In fact, something like 3 or 4 years of funding would be even better, even if it's not as much money per year, because again, it's easier to maintain things with mature software. We've also learned a lot about the importance of non-technical skills. Being able to do project management, community management. These are extensive skills that are not always within the wheelhouse of developers. They are also increasingly important with project maturity. And if you want to hear more about this, we did publish a paper in collaboration with Sloan Foundation that talks about our perspective and what we've learned about research funding for scientific software. Another aspect to this is, again, understanding the changing goals of an organization. And in our case, I'm personally starting to think about some of the specific areas in which CZI is interested for research. And this is in reference to our 4 scientific grand challenges that were just formally announced publicly a few weeks ago. And so those 4 challenges are listed here. You can learn more. These slides will be posted on SlideShare. You can find them under my name after this. But for each of these different specific areas of research, being able to understand what types of scientific software are important in them, and in many cases, in all cases I'd argue, it includes mature projects. In some cases, like the second up here, developing imaging, there's new technology being developed. That new technology requires new software. And so understanding the full software lifecycle is something I'm continuing to think about. And again, being able to assess impact for a very specific area of biomedical research. And so punchlines, what I'd love for you to take from this talk, the impact that I talked about today transcends many levels. It includes the entire open source science ecosystem. It includes open source projects, the maintainers of open source projects, the users of those projects. It also includes the entire research community surrounding them. We didn't even talk about commercial use of some of these software. Also, there's no single data source that'll be your magic bullet for understanding the importance of scientific open source. If you're looking for what statistic to track, I think you identify what that statistic or what that collection of information is, and you focus on that. Don't try to collect all of the data for all of the things, because you'll end up being disappointed in trying to compare yourself to other projects that just can't compare. Moreover, modest investments matter, more so than giving a huge chunk of money to one project that may not be able to use it effectively, because we can't always control what it is that the community needs. And then finally, the time is right now in where we are in the history of how open source science software is being developed. We actually have an idea of the life cycle, and I'm really interested in being able to figure out how we're going to see the impact of open source software over time as projects retire and as new projects come online. So with that, I'd like to acknowledge the other members of the Open Science team over the last 5 to 3 years. I'm open to conversation. I'm very easily findable online. There's only one other, Kate Hertweck, and she's like a music therapist, so no problems with like disambiguation. I'm happy to answer any questions.
I got a question back here.
Thank you. I had a question on, I think it was slide 12, the outputs produced by EOSS grants. What do you mean by submitted proposal and or awarded grant? Is that any, like a Fed or a non-Fed proposal?
Yep. That's one of the things we ask for in the reports we receive from our grantees. We are mostly told about proposals that are submitted and less frequently proposals that are awarded. And that's generally just because in the term of a 2-year grant, we're not going to hear about results for something that's been submitted during that time. And the grants generally range from private philanthropy all the way through to government. And these are globally distributed grants as well, so some of them may not even be US-based.
Hi. So I was referring back to the part about needing community management and needing kind of those skills that are non-technical. You said that you find these grants, a more modest grant over more time can be more useful, but what about maybe hiring people who are more long-term with those skills? Is that something that you take into account, or that these grant amounts can fund, or how do you kind of see the development of those skills?
It's an interesting question, and I'd say the way that I've seen these needs met is through hiring someone, sometimes on a sort of part-time basis too, because projects don't always know how to throw a new community manager in to the deep end for a project that's never had one. So sometimes it's hiring a person. Sometimes the bulk of the budget goes to hiring a community manager, say, or a project manager full-time. So grants are, the last few rounds of grants were 200 to 400K, and that's across 2 years. And so it's enough to hire somebody. We've also seen requests for support for folks to get trained in either project management or community management. And sometimes these are often filled by graduate students, which isn't quite the same as, in terms of budget, as hiring someone full-time. So it really is sort of a range of ways that those needs are met.
All right, so love this work. I'm so glad it's being done. As you mentioned, this is something that's often not funded, these like maintenance of mature projects. I'm curious, this report now has all this great data about why it's so impactful. Was it difficult to get that buy-in before you had that, or was this kind of part of CZI early on? I'm just, or do you have any either strategies or stories for, how to get that support for these really important projects that hadn't been getting a lot of attention before?
I think we were lucky in 2019 when this sort of first round of funding was being initiated, that an acknowledgement of the importance of open source and that it was not being funded in this kind of way, at least not in any regularized manner, through a competitive RFA. Like, that was not controversial at that point. I think this is also an interesting project in the context of CZI, because traditionally CZI does not do repeated cycles of things. There's only maybe 2 other examples I know of. It is more frequent that each RFA cycle, say that's coming out of cell science or imaging, would have been a new project. And so that we did 6 cycles of this was, uncomparable to any other RFA. I think that this work was overdue in the context of the overall program. But we can't make a strong message from 5 cycles worth of data. I think there's also lots of other ways to make the argument that we're making here. There are arguments from a risk-based perspective. What happens if you do not fund this piece of software? Like, what happens if you don't fund, something that every single project in your organization relies on? How much is it going to cost to replace that project if it goes downhill? And often it's really hard to assess that risk, which then you can leverage because it's a big, scary risk. And so again, I think there are lots of nice resources that very well articulate the importance of open source software, but having quantitative data, and specifically the vignettes are examples. There are a bunch of boxes that pop out in the full report that sort of identify some of those examples. Those tend to be the most compelling, honestly.
I think we have time for just one more question. So sorry, we can. I know we're in some sort of terrible stalemate.
You can arm wrestle.
Well, you just mentioned about requests by people to learn more about project management, community management, and I was just wondering what you suggest to them in terms of, if you give them the money, where they would learn those skills.
That is a hard one. There are some resources that I know of for community management. It's CSCCE, the Center for Scientific Collaboration and Community Engagement. And so they have courses specifically for scientific community engagement. I've taken their community engagement fundamentals course myself, and we have also paid for a few private cohorts of that for our EOSS grantees with very good responses. Project management is a lot harder, and I think that's mostly because the needs that folks have for project management are so nuanced depending on the nature of the project and how it's hosted. Like, if you have one person who's full-time paid to do project management, or even a team of folks who are all paid, is very different project management than a bunch of volunteers that are sort of ad hoc. We've been hosting a number of community calls to help support our grantee community in the CZI Open Science Program. And there are some resources that are coming out of that, things like how to manage a project when, I forget exactly what the phrasing is, it's when when you actually have no control over anyone. Like when it's a volunteer-based organization, it's worded much better than that, I promise. And I find some of those resources are nice because it aggregates across community experience instead of being a highly opinionated version of this is how you do it. There are a number of books that are coming out related to open source software, but again, I think scientific open source software is a specific beast within that, and I have strong opinions about that some people try to argue with me about. So if you want to arm wrestle about that, then I'm also happy to. We've also been piloting a project management course as a part of our movement and capacity building series at CZI that's had some good response. But again, I think the cohort, the people who are selected for that course, are of a specific type. So I wish there were better things to say, but it's still very much choose your own adventure.
Thank you so much. Can we give Kate a huge applause? All right, thank you everyone. Thanks Kate, that was an amazing talk. We are now going to transition into an experimental portion of the agenda known as lightning intros. So we really wanted to give a space to allow people to do brief introductions who might not be a speaker or might want to tell you something about themselves that's different than the talk that they gave or their official capacity that they showed up in. So we hope that this will facilitate some new connections and conversations during the reception. So the way this is going to work is if you emailed me to join the list or signed up on this sign-up sheet today, I'd like you to stand up and come form a line going this way, coming towards me. You don't have to be in any particular order. And what I'm going to do is I'm going to hand out a mic. You will have 30 to, I'll give you a moment to get situated, but I'll do a demonstration. You are each going to have 30 to 60 seconds. 30 to 60 seconds, so very, very quick, to give a bite-sized introduction to yourself. You may use this time however you would like. But one suggested format, if you're looking for structure, is to say who you are, where you're from, what you would like people to come talk to you about, and then what are the sort of people that you want to meet. So I will go first as an example, and then we'll get this party started, and we will be gently, or not so gently, interrupting you if you are going much longer. So, okay, great. My name is Emily Lovell. I'm the Associate Director of the OSPO here at UC Santa Cruz, and I would like to, you should come talk to me if you're interested in supporting the next generation of contributors in open source through teaching and mentorship, things like that. And I would like to talk to people who have experience with scaling programs around education and training, and people who are still doing the work around inclusivity in open source.
Can we applaud?
Thank you for your applause, but please hold your applause because otherwise we will be here for a very long time. We'll do one round at the end.
Hello, hello. My name is Katerina. I was going to speak to you all, but now I feel like I need to speak to you all down there. I work for G Research, which is a fintech company based in London. I work with the open source team, and come talk to me if you are interested in academic engagements with industry, projects in infrastructure, data, and AI stuff.
Hi, I'm Jared Millman, and I am the Executive Director of UC Berkeley's OSPO. I'm also one of the co-founders of the Scientific Python project that Fernando Perez mentioned this morning. And so I'd be happy to talk to you about anything open source program office at Berkeley, as well as anything in the Scientific Python ecosystem. If you're doing Scientific Python programming and work, come talk to me, please.
Hello. Should I start? My name is Yahya. I'm from the Schwartz Center for Computational Neuroscience at UCSD. We developed EEG lab used for 80% of human neuroscience electrophysiology research. But what you might not know, we also host nemar.org, which is about 30 terabytes of EEG EMG data, and it is being used for many people, and we process data as well. What more interesting, we have technology for labeling data as well, which is called heads.org. I'm very interested in data quality management systems, which is not being used or just being given out advertised. And there are a lot of crappy fair data, so please, if you want to talk about quality management systems, find me. If you want to talk about chalk factor / the library factor, yeah, I really like to talk about that as well. Thank you.
All right. Hi everyone, my name is Monish. I'm a third year computer science student at UC Davis, and I'm also the president of CodeLab. So CodeLab is a software and design agency at UC Davis, and we try to provide students with real-world hands-on experience with industry work. So we believe we got the secret sauce in trying to get these industries to work with educational institutions, because over the years we've done over 60 projects, 25 different clients, and this quarter we're working with Snapchat, Reddit, Genentech, Chevron, GoodNotes, and so much more. So we also launched our open source program. There's over 130 devs waiting to work on projects. We hit a bottleneck of not being able to generate as much projects as we can. So if any one of you here are interested in helping us out with projects or helping us give tips to us on how we can improve our open source community, then feel free to come and talk to me about it. Thank you.
Hi everyone, my name is Hong. I am from NASA Ames Technology Transfer Group. I am the one of two software release authorities that are working. So I work on software release for open and closed source, and then I also help with licensing and marketing. So come speak to me if you want to learn more about NASA partnerships or any type of agreements.
Hi everyone, my name is Kat Allman. I'm VP of Open Source at Digital Science based in London. I'm based in San Francisco. If you are curious about unconferences as a driver for interdisciplinary collaboration, talk to me about that. And I'm particularly interested if anybody has thoughts on the growing tension, particularly in the EU, between the desire to control open source, use it as a driver of economic development, and at the same time, digital sovereignty. So talk to me about how those do or don't fit together.
Hi, my name is Becky Grady. I work at the California Digital Library, which is part of the UC Office of the President. I am the service manager for the DMP tool, which is a free open source piece of software. Before I joined CDL, I was a product manager and UX researcher in the video game industry. So come talk to me if you want to learn about the video game industry or just want to talk about what video games you're playing. I also would be happy to hear from anybody who has thoughts on how to talk about open source software in data management plans. It's a big area we're exploring about how to make sure that software is accurately captured in funder policies and included as part of data management plan templates.
All right, so my name is Chris Holgraff. I have like maybe 7 or 8 different hats that I could be wearing, but I'm going to focus on 2 of them. So I spent probably about a decade at UC Berkeley working with a bunch of different open source teams and projects there. I'm the co-lead on a bunch of different projects in the Jupyter ecosystem, most notably the Binder project, the Jupyter Hub project, and the Jupyter Book project. The 2 hats that I have, one of them, I'm the executive director of a nonprofit called 2i2c, and we manage an international network of community hubs for interactive computing and research and education. So we work with communities to give them a hub that provides them access to shared environments, shared data, shared computation that they use to do their work. And if you're interested in talking about how you can work with a nonprofit that uses open infrastructure to provide hubs like that,
I would love to talk. Secondly, I represent the Jupyter Foundation, and I'm a member of the Jupyter Executive Council. And these are two relatively young groups. They're both kind of co-leading different parts of the Jupyter project, and I'm interested in learning about how these groups can be impactful for research and education in the academic community, and try to find ways to basically build bridges wherever we can. So I'm still learning in that role. I'm relatively new in both, and I'd love to learn from and discuss with you all how they can be more effective.
Hello, I'm Jeff Shapiro. I'm the Director of License Scanning at the Linux Foundation, otherwise known as the License Guy. Come talk to me if you want to know about open source licenses, if you want to know about compliance, if you want to know about auditing, excuse me, if you want to know about software bill of materials, SPDX, any of those things I'd be happy to talk to everybody about. If you want to talk about something completely different, feel free to come talk to me about Monty Python, martial arts, astronomy, and board games. Thanks.
Hi, I'm Katie Dobry. I work for the California Digital Library, which is at the UC Office of the President. And we're interested in open library metadata and software to work with open library metadata, which is a very specialized thing. But if you're interested, come talk. I'm also working on an open source project, which is like open source Libby. Many of you who use Libby from the public library, we're trying to make that an open source thing, so come talk to me. And finally, if you're driving to San Francisco and you could give me a ride.
I'm Joel Cayley. Hopefully also my talk earlier today, so just shortly, I'm from UCLA and Tech Transfer. If anyone wants to come talk to me about all things tech transfer, I'm more than happy to do that. And and Emily, if I say this right, you'll realize I want to talk to you about this. I've become very curious listening to the talks today about the ecosystems around a successful project, because I see that as a microcosm of really being a good citizen in the digital commons, which I think is very important. And so everything from how people are being trained to tools that can be leveraged to maintain successful ecosystems. I'd love to have conversations with you about that. Thank you.
Hi everyone, my name is Natalia Lizaryaga, and I'm a software engineer in the digital service at the Centers for Medicare and Medicaid Services, where I am part of the open source program office of the agency. Come talk to me if you're interested about learning how we are launching and growing the open source program office at the Centers for Medicare and Medicaid Services, because we are the first of its kind in a federal agency. So super interesting challenges we've been going through, especially with some policy that has been released. Some interesting projects I've been working on is promoting software reuse among different federal agencies and creating metadata standards to do that type of inventory work. And I am interested in meeting with other people that are part of open source program offices. I am early in my open source career journey. This is my first job, so I would love to get to talk about open source in an open source program office context with more seasoned professionals. Thank you.
Hi, I'm Randy Hybe, CTO of Networking and Edge at the Linux Foundation. Please come talk to me about anything open source, specifically about the Linux Foundation. So if you always wondered what exactly does the Linux Foundation do and were too afraid to ask, tonight is your chance. Also, if you have cool ideas for new projects you want to contribute to the Linux Foundation, or just want to rant about things that you think we can do better, I'm here to be your punching bag tonight.
Hello, let's do tenor script. It's me. Hi, I'm Mihai Marusak from Google Open Source Security Team. I'm a maintainer on several open source projects like TensorFlow and Guac and model signing. And I'm interested in talking with anyone that's interested in this tool of open source security AI. Thank you.
Hi, everybody. I am Martha King. I am part of the founding team at CASA, which is the Collaboratory for Open Software and Systems in Food and Agriculture, joined actually by our other two founders, Rob Trice and Drew Zabaki, who you'll hear from a bit tomorrow. But CASIF was founded because we believe that food and agriculture urgently need open and collaborative approaches to digital innovation. So we are a nonprofit that brings together growers, the tech community, academia, and industry to co-create solutions through open code, pre-competitive pilots, and collective impact. So one of our flagship projects is actually the Supply Chain of the Future, which is a global initiative tackling some issues like data sovereignty, interoperability, traceability, all that good stuff in food and ag supply chain. So come talk to us if you want to talk about open software and systems in food and agriculture.
That's tough to follow. Very good stuff. Hi, my name is Marvin Barksdale. I know most of you are sick of hearing me talk, so I will be quick. But I am the Director of Business Development at Mass General Brigham and the architect of our OSPO that we're rolling out. I am happy to talk to anyone about tech transfer issues, OSPO issues. I've heard many of them from people that came before me, but I am most interested, what I haven't talked about is working with students and getting student developers involved in the many projects that we have now. I know I've talked to a few before, but always open to talking to more.
Howdy folks, my name is Wesley Chun. I'm a twice UC grad, did my undergrad at Cal, grad school at UC Santa Barbara. Also have a parallel career as a teacher, so I've also taught for UC Santa Cruz Extension and Santa Barbara Extension. Right now I'm a Red Hat TPM in the OSPO team, focused on upstream AI open source projects. We're sponsoring, so I was told they needed a warm body. So that's why I'm here. I came from 12 plus years at Google in DevRel, spending time focused on higher ed. I was one of the original initiators of getting GCP credits and other resources to faculty, students, and researchers. So come talk to me about Google, Red Hat, AI, open source, and I also wrote a couple of Python books, so you can talk to me about that too.
Hi, we're Stefan, Miriam, and John. We're from the UCSF Education IT team. We're incredibly lucky to get paid mostly to write and maintain open source software, mainly the Moodle LMS platform and Ilias learning management system. It's a great job, and we love it. We're happy to talk to you about that, or you can come show us pictures of your dogs, I think would be fine with us too, so whatever works for you. All right. Thanks for having us.
They had three. Hi, I'm Edwin Espinoza. I work at Cal Poly Humboldt, which is in the CSU system. And come talk to me. I'd like to talk about introducing the OSPO concept to the CSU system. So if you want to talk about that and just general talk about open source and inclusivity, I would love to discuss those topics. Thank you very much.
Hi everyone, my name is Jadine Young. I work at a company called Lyrasis. It's a nonprofit. If you're a part of Curious, you might have heard of my colleague, Bridget Almas. She presented on our organizational home, which provides operational infrastructure to support and enable communities who are working on open source technologies. I'm interested in talking to people who would like to contribute to some of our existing programs, which include Fedora, Vivo, Archive Space, DSpace, and Collection Space. We work really highly in the realm of library, archives, and museums. Hey, Libby folks over there. So we're always looking to add to our organizational home. We also offer hosting services for a few open source technologies. If you don't want to talk to me, or you don't want to talk to me right now, I have handouts. So come find me.
Hi, I'm Alden Connor, most recently of the Alan Turing Institute in London, where I was a research application manager. And you're probably thinking, what's a research application manager? I was the second one ever. And it's based on the idea of a product manager, but bringing a lot of those skills and functions into academia and into open source software development. So I'd love to talk to you if you want to learn more or think about what we call research infrastructure roles, these team members who are not developers, but can help with a lot of the stuff we saw Kate talk about. If you're thinking about adding these kinds of roles to your project, I'd love to chat with you about it.
Hi everyone, I'm Juanita. I was a developer for Spider ID
for a couple of years, the E for Python. Now I'm a PhD candidate at UC Santa Cruz, and I work with the UC network in discovering the open source projects within the academic system. I'm interested in open source security, so my goal is to understand how does security look within academic open source projects, so come talk to me about that.
Hi, my name is Nada Milkovich. I am the project manager for the Center for Innovation and Entrepreneurial Development at UC Santa Cruz. I have a long history of being a project manager and am really excited about teaching students how to be really good project managers and collaborators and communicators. I'm very interested in learning more about how to develop business plans around open source projects, and if you'd like to talk more to me about project management and how I use open source for teaching, I'd love to talk to you. Thanks.
Somebody after me, okay. So yeah, hi, my name is Arun Gupta. I run the developer programs team at Angel. So anything to do with developers is where my team gets in. Events, developers, hackathons, academia, all sorts of stuff happens out of my team. I built and led open source strategies. That's the part of my title right now at Intel. But prior to that, I built the first OSPO at Apple. Prior to that at Amazon, so I've built OSPOs all along. And I used to be part of the original Java team, so I've built part of the OSPO there as well. So all along over the last couple of decades, that's what I've done. Something I'm very passionate about is open source culture. And I think somebody asked the question over there, hey, I'm part of IT. How do I build that culture in there? So I think that's something I'm very passionate about. Talk to me anything about that. On a personal side, you can ask me about my Kilimanjaro trip that we did last summer, or my Antarctica trip that I did last month. So, or you can talk to me about running or fitness. So talk to me about anything open source or fitness. I'm game. Thank you.
Cue round of applause.
Thank you. Wow. Thank you all so much for keeping to time. That was pretty amazing, actually.